We learned so far how to do read of a voltage that is between 0 and 5. That's an analog read. It's some voltage in that range, and it could take on many possible values inside of that range. Now let's learn how to read a voltage that is either 0 or 5, which is going to be what we'll call a digital read, or it's a binary value. It's either on or off, high or low, 0 volts or 5 volts. So first of all, before writing any code or anything, let's figure out what will our electrical setup be. We'll have an Arduino, and the Arduino has a 5-volt pin. It has a ground pin. We will connect the ground to some network of other things called ground with that symbol, and the 5-volt pin will connect to other stuff with that symbol. Now we can do the digital reading we want on actually any Arduino pin. We could use pins 0 through 13 on the right side of it. Those are all possible pins, though we tend to avoid using pins 0 and 1 unless there's a good reason, because those are used for communication. We can also, and this is an important note, you can do a digital read or a digital write on any of the analog pins that we draw typically on the left side. So actually, you have lots of choices, 20 choices to put a point on it, for places you can connect inputs to the Arduino. Digital inputs, digital outputs are available on any of the analog and any of the digital pins. So I'll just choose digital pin 8 for no special reason. And what we're going to do is either want there to be 5 volts on that pin or 0 volts, ground, on that pin. And what I'm going to do is actually just take a little wire and either connect that little wire up to 5 volts, or I'll take that little wire and connect it down to ground. So this isn't like truly an electrical schematic drawing of a wire or something. You wouldn't want to connect those things to each other like that. But what I'm telling you is that I'm going to just physically do that. And how that will look on the board is like this. I've got 5 volts here using a red wire going over to this column, this power rail on the right side of my breadboard. I've got a ground here, which I'm using a black wire to connect that ground to the left column of the breadboard. And then I've connected a yellow wire to pin 8, and I'm just going to physically plug that wherever I want on the board. So really, really simple circuit. Now let's write the software. This is also going to be pretty simple. We're going to just do a digital read of pin 8 and report back to the computer. Simple as that. So in the setup, we will say pin mode 8 is an input. And because we're going to be reporting data back to the user, we need to turn on the serial communication system. So I say serial.begin. 9600 is the standard rate that we use. Void loop. Wow. We're going to do a digital read of pin 8. So digital read, hopefully it looks kind of like analog read. It's not identical. It's like the digital cousin of analog read. And digital read will either give us a high or a low back, whereas analog read gave us a number that could have run an entire big range, 0 to 1023. Digital read has only 2 possible answers. It's a binary value, high or low. And just like we did analog read, we have to save that value into a variable. Otherwise, it will do the digital read and then discard the result. So we're going to save it into a variable. By the way, some cats enjoy eating wires. Do you see what's happening here, buddy? Yes, they enjoy eating wires. Be careful with wires and cats. Fun fact. So what we're going to do is save this result of the digital read into an integer variable. We'll call it read val. What I'm doing on this one line is actually 3 different things. I'm making a new variable, I'm doing a digital read, and I'm saving the result of the digital read into the variable. So that will be making a I just want to leave a note, because usually we've done this in 2 different lines, but we can actually do it all at once. Saving a value into it. And then I'll do serial.println read val. And then finally, I will have a delay. I'll just have a 10 millisecond delay because otherwise, if we're peppering the serial port with data too fast, it kind of becomes annoying and difficult to read. Also, you should know that if you do a digital read or an analog read of a pin very, very, very fast with no delays in between, that can actually cause electrical trouble. It won't like explode the Arduino or something, but you can get weird data out of it. So I'm going to do the split screen view so you can see the upload process, which is nothing new. I will go ahead and upload the code. I get some blinking over here that tells me the upload is working. And now I see the TX light is on. Is it actually on steady? No, it's actually transmitting 100 times a second because the delay is only 10 milliseconds. And now I actually want to see the data that's coming back. Instead of using the serial monitor, which would show me just the numbers, I want to look at the serial plotter. I want to see the graph of the data coming back. My serial plotter opens in a different screen, so I have to drag it back over here. And I see this weird jagged line. Please note the y-axis values over here. It's 0, and that number there is a 1. So on the right, this is a wire that's plugged into nothing, and I'm getting weird jagged values. What will happen if I plug this wire into this row on the breadboard? There's nothing plugged in, weird jagged values. What if I plug it into this row? Aha. If I plug it into ground, I get a nice steady 0. Every single digital read is a 0. What if I unplug it from ground? It's all over the place. And if I plug it into power, a nice steady 1. Every single read is 1. So what we are observing here through this experiment is that when a wire is unplugged, when we do a digital read of something that's not plugged into anything in particular, we actually get ambiguous or floating data. It's a floating input. So it's very important that your input is always connected to something. Without connecting it to something, you will get weird data. So it's not harming the Arduino to do this digital read with nothing connected to it, but certainly that's not like useful. So what we're going to learn next is how we can actually get a steady digital read that is switchable between high and low, and that doesn't require you moving a wire from one thing to another. Let's use an actual button instead of doing this wire moving trick. And then we can use that in our software. And then the button can activate something in the same way that the potentiometer could adjust something.